Okay. Well, there likely won't be a lot of traffic noise. It's about 11 p.m. Memorial Day. Although, just as I got started here, it started raining. So I'm in the garage here, you can hear it. I can hear it. Sorry about that. I've done quite a bit of work on this beastie. This lovely gal. And she's working much better than she were, a few days ago. The part I ordered finally came, this transformer, and this is the reverb tank driver transformer. That installed without a hitch, no troubles at all. I did went ahead and installed these properly. These fit, they're a good fit. I'm going to leave them. These three, they're 10 microfarads each. They really want to be 20, although this thing works great with it. We'll go ahead and order. These are used. Ones I kept. They work just fine, but we've done enough time on this gal that I think it warrants. Just go ahead and order appropriate caps for this. New ones. These two are just fine. They can stay, but I'm not real happy with these. Just they're not to spec, although they work. You might be able to tell there are only two tubes in here. Down in that end over here, that is just a solid state rectifier tube, just to supply DC voltage. It was something I wanted to demonstrate. Some folks working on these may not be aware of, or if they are, I hadn't really thought about it too much. As I said, there are only two tubes in here. This one is the preamplifier stages. There are two triodes in this. It's a twin triode. It's a 7025 slash 12AX7A. Both are high gain dual or twin triodes, and both of them are geared for low noise, low hum, low microphonics. Your mileage may vary. Mine certainly does. I have in here a known very good one. It's branded Motorola. I think Sylvania made these, maybe RCA. It doesn't matter much. These I know work, and they're very quiet. This is a 12AT7. That is a dual triode. It's also a high gain triode, but it's interesting that the curves on this differ from these in that they're sort of long tail. It has a sort of semi-remote cutoff, but what they're doing with this tube here in this circuit is they've got both of these triodes connected in parallel. Both plates tied together, both cathodes tied together, and both grids tied together, the control grids tied together, just to make a power tube. And it puts out something maybe 3-5 watts through this. And that's what drives the reverb tank. Just to do a little demo, I thought, just to show, there are no power tubes, no other tubes except these two. The two preamp stages for the effects input, into which I've got a plugged in pickup for my acoustic guitar here. And rather than connect the reverb tank to this transformer's output, I've connected it to an 8 ohm speaker. It's a little 8-inch public address speaker. Is all this is. There's nothing between here and the output of this. Just to show that this is all by itself an amplifier that has enough drive to drive a speaker. Hey, you're not going to get concert hall levels out of it or anything like that, but for a little practice amp, it could work. Just keep that in mind. Who knows? Let it wander. So I'm going to set this aside just to get it out of the way so I can see the controls here. You can see it's just clip leaded in. This is the line that drives the reverb tank's input. Geez, I gotta go all the way around yonder to turn it on. Oh, by the by, right now we're operating with no ballast. Just put a fuse in there just because it's convenient. I think it's a 15 amp fuse. There's also a fuse, I think 15 amp in this Variac. But there's also a 2 amp fuse in the amplifier here, in circuit. I did go ahead and install a line cord on it, 3-wire line cord. The chassis is grounded. I disconnected the death cap. It's still in there physically, but disconnected. So we don't have to worry about that. So let's see. I'm going to set this to about 100 volts. I've got the solid state rectifier in it, and just because it's only got 2 tiny little tubes in it, if I turn this all the way up, the voltages will get a little higher than they need to be for this demo here. So on she goes. There's the rectifier's heater indicator. It just says, kind of say power's on. Don't touch it. Yeah, pardon me. Okay, so that's just front end for channel 2, the effects channel, and the tube that drives in class A this transformer, whose output right now is connected to this speaker here. I don't know if you can hear that or not, but so this would be the signal that is fed into the reverb tank. You get the idea. So keep this short and sweet. That's the kind of output that just this part of this amplifier has, and all of that. Of course, this front end also drives straight through, but it couples in this front end. Not only drives downstream, it drives this tube, which is a Class A power amp, feeding this matching transformer that drives the speaker side of the reverb tank, and it's got enough power. It's through an 8-inch 8-ohm speaker. It's not bad. Now you can hear some distortion there. Maybe back off on some of the tone here. So, enough of that. Just wanted to do a quick demo of really what this is, this reverb driving circuit, and what failed on this ultimately was the transformer, the original transformer. The input got zorched. The tube got zorched. The socket got cooked, although it's still functional, and I'm going to leave it alone. These mica nil sockets are awesome. They're not phenolic. they're not ceramic, but that would be ideal. But these Myconils, they with a bit of exposure to some heat, they'll discolor some, they'll turn dark, but that's still a long way from arcing through and shorting. And the voltages on this tube they're not terribly high, so I don't see that's going to be a problem. So anyway, I'm going to shut this down for now. Put things as they should be, plug all the tubes in, flip it over, and show some of what is going on underneath the hood. Back in flash. Okay, and moving right along. First, rant time. For some reason, Fender didn't see fit to put the pin numbers on the tubes. That's a real pain in the butt when you're trying to service stuff. Interestingly, if you've got a copy of the layout, it has the pin numbers, but it doesn't tell you what pins do what. So you kind of have to go, what this is, okay, look at this, and you look at that, and you look at this, and you look at it. No. Put the pin numbers on the damn schematic, will you? Geez. No position numbers or anything. What valve is it? Which position? It does nothing. It's how they drop the ball so many places with these amps, and then picked it up in others. I mean, good Lord knows they sold a hell of a lot of them. But anyway, this is the drawing I've been working with. There are a number of permutations of this amp. This one, it's AMP AB 763. There's an AA 763 and there's several others. Minor differences, but from when I've been all over this amp, this drawing matches this amp down to the last disc capacitor. So enough of that. I just wanted to point it out. And I looked around online. I mean, somebody has to have done this before and labeled things appropriately, but no, not that I could find. So you may not be able to see this clearly. Maybe I'll append again a clear photo of this if it helps someone. Anyway, I'm going to cut this and paste on stitch on later in just a second, just to make sure that I'm looking at what I want to be looking at here. Okay, I guess that'll work. As I mentioned, I've been all over this amplifier, and very interesting discoveries. No surprises, just interesting. It did redo all this, the grid bias for the output tube circuit. That resistor was out of spec. The diode was it was okay. I put a modern one in there, the one in 4005, so certainly able to handle that. It gets a 500 volt part, and put a 150 volt capacitor rated in there. You know, Fender put a 50 volt capacitor in there. That thing sees between 60 and 65 volts the moment you turn this thing on. That's bad. They cheap Charlies. On the other hand, see all these blue molded capacitors? I'm pretty sure those are paper foil. Every single one of them is good. Golden. I mean good golden. I lifted them out and did a full comprehensive check on them. They're as good as gold. I don't know who made these. I've The only place I've ever seen these is in Fender amplifiers. So who knows? Maybe it's some guy in his dungeon making them or something, but whoever it was, they did it right, because every single one of these, the equivalent series resistance is it's nil, not even measurable by my instruments. They don't leak. All of these are rated for 400 volts. I've tested them for leakage up to 500, nothing. This guy too, this, I don't know, let's call that a brown drop. I'm not sure why they chose that particular type for there, but at any rate, as I go through these, I mark what I've looked at, what's okay, and you might be able to tell there's some red color. It's just red Sharpie. If I replace the component, it gets a red mark on it. If I've checked it and it's good, I mark the leads red. If I've hit a solder connection, it gets marked red. And as you can see, there's quite a bit of blood all over this thing. I did not need to replace any of the ceramic capacitors. That's rare anyway. Obviously these paper molded capacitors, didn't have to mess with that. Resistors, oh boy. To give you an idea, I went through and measured resistors, and let's see, I'm going to pick out everything that's not a resistor. These are what I had to replace. Every one of these is out of spec. Majority of them are 10% tolerance, plus or minus 10%, and they're way off from that. I don't think any of these were 5% tolerance. But nevertheless, this thing, it was a bit noisy, particularly on the effects channel. And well, that turned out to be one or more of these. And some of them are so far off, it's ridiculous. I may add a little bit of a clip to demonstrate just how bad things can be. So basically, this whole bit of the circuit's gone through. I've checked every single component on it. But for these ceramic discs, and those things, they fail, but they, you know, it gets struck by lightning more regularly than that. So, especially where they are in circuit, they're not rode hard and put away wet, as this amp has been. So anyway, it's all working. I've already plugged everything in, and it's working. I don't think there's much more to do here. I'm not. I've mentioned this before. I'm not doing any cosmetic work on any of this. The goal here is just to well, originally it was just to see if it could work. Then it became an obsession. Oh yeah, we're going to make this work. Especially finding out that the big iron is good, and all we had to replace was a little piece, and all the tubes, and a handful of resistors, and a handful of electrolytic capacitors, and a little bit of cleaning, some pots, and phone jacks, and yeah, she's working, and I will certainly demonstrate that. But I also need to do a full power an output test. You know, how many watts is this thing going to put out as is? I think it's probably going to be as rated, probably about 40 watts. I will certainly measure that and show it. I think for now I'm going to cut this. I may, depending on length, stitch this on to the next clip. If not, this may be, you know, a number 7, I think. Or not. See it.